Hey tubers, today I want to cover top selection sort algorithm. There are many sorting algorithms, but I think this is pretty easy to grasp. I'm not going to go in much detail about the running time and all that. I just want you guys to understand the big picture of selection sort and briefly go over how it works. So suppose you want to sort numbers in an array. Say we have an array like this, and we're gonna fill this with 6 numbers. So 1, 2, 3, 4, 5, and 6. We're gonna number these indexes starting from 0 to 1, 2, 3, 4, and 5. And we want to sort this array in ascending order. So let's fill it in. Let's use blue here. Let's say we have 2, 4, 1, 7, 0, and I don't know, 6. Okay, so the way selection sort works is it will traverse the entire array and you will find a minimum number in that array. So in this case, it will go through the entire array, it will compare all the numbers inside the array, and whenever it finds the lowest number, it will swap the numbers from in this case it will swap number at index 4 to index 0, because the 0 is the lowest number in here, and it should belong to the 0th index in the array, which is the first element. So the new array, and then we need a way to so the reason why it gets swapped, because we can't have a hole here. Okay, so let's make a new array. This is gonna be translated into the following array. So this is gonna be 0, then we're gonna have 4, 1, 7, 2, and 6. Notice how the numbers got swapped. Okay, label this. Okay, so this, and this got swapped. So now notice that on the left hand side we have 0th index, we have 0, which is the minimum number in this array. So we already know the left hand side of this array is already sorted, so we don't have to consider this any longer. Now we can traverse the array in this part. Okay, we don't have to consider it on the left hand side because we know this is already sorted. So now it's going to go through the array again. It's going to traverse, it's going to find 1 to be the lowest number in this remaining array at index 2 by comparison. So it will be swapped with the number at index 1, because next lowest number has to be adjacent to the previous lowest number. Okay, so let's make a new array here. This is gonna come over here with the following array: 2, 3, 4, 5, 6. So our current array is gonna look like this. So 0, 1, 4, 7, 2, and 6 with the following index numbers: 4 and 5. Now we don't have to consider the left hand side of this array because we know this is sorted, and we just gotta repeat the same process as we've been doing before with the remaining part of the array. So now what's gonna happen is it's gonna traverse the remaining part of the array. It's gonna find the 2 to be next lowest number by comparison at index number 4, and it's gonna swap index number 4 with 2, which is these two numbers right here are gonna be swapped. Okay, because 2 has to be the next lowest number from the previous lowest number. So let's draw a new array here. Let's change up the colors here. Let's make this array blue. Okay, so 1, 2, 3, 4, 5. I'm getting a little sloppy here. So we have 1, 0, 1, 2, then then we have 7, 0, 1, 2, 7, 4, and 6, because these two got swapped. Okay, well, this array should be here. Okay, with following index numbers: 4 and 5. Okay. So now again, we do not have to consider the left hand side of this line right here because we know this is sorted. So one more time, again, the algorithm traverses the array to find the next smallest number by comparison, and it's going to find 4 to be the next smallest number at index number 4, coincidentally. So a new array is going to look like the following. I'm sorry for drawing all these arrays, just for an example. I think it makes things a little bit more clear. 3, 4, 5, 6. I hope I didn't mess that up. So now these two numbers are gonna be swapped. Okay, so we're gonna have 0, 1, 2, 4, 7, and 6. With index numbers 0, 1, 2, 3, 4, and 5. Now again, we do not have to consider the left-hand side of this array, because we know this is already sorted. So we only have to worry about the right-hand side. With two numbers remaining, the algorithm is going to traverse the array one more time, and it's going to find 6 to be the lowest number, index 5, and it's going to have to swap with the index number 4, because that's the only two elements remaining in this array. So these two numbers are going to be swapped, and we're going to be left with the following array. 1, 2, 3, 4, 5, 6. So we're gonna have 0, 1, 2, 4, 6, and 7, with index numbers 0, 1, 2, 3, 4, 5. And now we know, since we only have one element to traverse remaining that has not been swapped or anything like that, we know this has to be sorted, because there's only one element left right here, and there's nothing else to compare this element with. So we're done. So this is our resulting array that is sorted. The running time for this algorithm is big O. So running time is big O of n squared. It does a lot of comparisons. Thank you for watching.